All right, my name is Mike Clarke. Thanks for introducing me, Jim. Last year when I was at the conference, I met with Andrew Fee. I was pretty impressed with some of the stuff that he spoke about, and led to a few conversations and then some calls over the phone and transfer some data, and this is sort of what we were able to come up with. At Teck Coal, with Teck Resources, we always start with a safety share for all of our presentations. And driving from Phoenix on Saturday morning, saw this, and it's either incredibly safe or incredibly unsafe. But needless to say, I didn't want to drive behind that guy. So my wife took a picture as we were going by him. So I'd never seen anything like that before, but I'm told that that's not rare. So I'm a geologist at Fording River. Primarily I've worked there since 2007. I've mostly done model building. I worked in coal quality for a bit, and I've also done quite a bit of surface work with LGOs, and I've probably called the help desk too many times to complain that my 27 kilometer by 17 kilometer LGO, it doesn't work, and it's 9 gigs or whatever, and that sort of thing. I graduated from the U of A, the one in Alberta, green gold, in 2003, and not the one down here. Before coal mining, I was in oil and gas for 4 years. I was an open hole geophysical wireline logger, and I also did some exploration development geology work, and what I did was multi-legged horizontal heavy oil wells. So drilled horizontal, have multi-legs that come out. That was at the Canadian Forces Base Suffield. I've also had experience with measuring while drilling and logging while drilling. This is pretty neat stuff. And currently I work as a member of the cross-functional team for SWIFT at Fording River. And basically we've got a long-range guy, a short-range guy, and a geologist, myself, all working together on geology and engineering problems together. So we don't really, there's a lot of blur in our roles as we work across. Right now I'm doing a lot of engineering work. And I have a wife and 2 little boys. They're the white blonde kids at the pool, if you've seen them. So Teck Resources, we're Canada's largest diversified resource company. We're 100 years old this year. We're headquartered in Vancouver, and then we own or have interest in 13 mines throughout Canada, US, and South America. And one kind of thing that I thought was neat, because I went to the Olympics, but in 2010 all the medals were donated by Teck from our operations, and all of the medals actually incorporated some recycled electronic material from our trail smelter. So here you go. Shoot, wrong one. This is the Elk Valley down here. We've got 5 mines, like Andrew mentioned. We also have a project up in northeastern BC and a mine in Alberta. I'm at the Fording River mine, and this presentation is going to sort of deal with us and the next mine adjacent to us, Green Hills Operations. So Fording River, it's a large truck shovel operation. We do about 700 kilotons per day, and we do metallurgical or steelmaking coal. And we began in 1971, and we produce over 225 million tons of clean coal. We've got 7 shovels, 48 waste trucks, even the big 797s, 5 drills, and 18 D11s to clean our coal. So this presentation, I'll sort of spell it out here. It's Mintec designed coordinate transformation scripts for Teck Coal based on a transformation algorithm that we developed with a contractor. And we've used these to build a combined model and pit designs over an area that's been surveyed in 2 different methods or coordinate systems. And the ultimate goal eventually is to have us convert both Fording River and Green Hills operations to the UTM NAT83 grid. And then all of our mine planning objects and models must be converted so that when we start operations in this SWIFT area, which is directly north of Green Hills, that our planning is absolutely seamless. However, we don't really want things to be seamless. Yeah. So I'm glad I got some last. That's good. So first of all, that's sort of our challenge to go, and then what we want to do is make a combined model. So we need that algorithm, and then from the algorithm we need the converter, and then we want to talk about what it actually can convert, and then how this scripting has helped us and sort of what we've come up with. So the two mining areas were in different coordinates. Oops. And big blue here, that's Fording River. And down here in green, this is Green Hills Operations. So both sites started with different ownership and different ideas how to do things. And our coordinate system for both sites are different. And we want to be able to build a combined model for two operations in the same area. So we needed to easily update and share interpretation between our operations in order to do that. So we needed a couple things. We wanted to be same mine grid coordinates, so our projects are right over top of the same area. We want to have the same model orientation or grid set with the model, and they weren't the same originally. We want to have same bench heights. Swift and Fording River is an area that was previously mined that we're going to reactivate. Well, its bench system was different than what Green Hills is currently mining. We want things to be able to join up and be nice together. And then we also need to have the same seam naming system. And it wasn't even close to start. So the first thing here, an algorithm from Airborne Imaging. So it's actually an X, Y, and Z translation. And then there's a rotational factor, because our norths weren't the same from both sites. And then we needed to do a scaling factor. There's a bit of a crunch to compress it. And then there was also a geoid correction, which Andrew mentioned. And so that's, I won't really talk about it here. If you want to talk to me about it, I get super excited about talking about this stuff. But it's orthometric versus pseudo-orthometric or an ellipsoid variation. So it's basically how the shape of the Earth, how we assume it is. You know, a lot of people think it's a sphere. It's not a sphere. It's actually fatter around the equator than it is from north to south. But then that's absolutely smooth. Well, the Earth isn't actually absolutely smooth. It's a different projection. So yeah, I don't know. I find that stuff neat, but most people here probably don't. So we also needed to work in the same coordinate system, and this is where the scripting has really helped us. So the drill hole database, we wanted to be able to have it work for both sites, and we use an acquire database. And so then we can have an easy way to share information between both sites, and then it's going to be a lot less time consuming than exporting the drill holes from the database, putting it into Excel, doing your ad hoc conversion, and then getting it back into Minesight. It's really cumbersome to do that. And then this will also be an easy way for us to update our qualities through the model. So right now we've temporarily changed all the drill holes at Fording River operations for our Swift pit to the same site grid as Green Hills operations. And so we've converted all of our Minesight objects to this other grid. And eventually the vision for us is to have both sites running in UTM NAT83. And the reason why we picked this is it's a government and external party communication. That's what they want to see everything in. Standard GPSs that you just go by for camping and stuff, they all will work in this. And it's also going to give us a consistent elevation datum for all the areas, which we also don't have. So here's a screenshot of the awesome script. We can do multiple files or single files. You can do a folder and for multiples, and it will go through and it'll take all of the subfolders, any MSR objects that it encounters, it'll convert. And you can tell it to either overwrite or you can copy the files. And then down here, we select what kind of conversion we'd like to do. And we actually have this developed for going between Fording River, Green Hills grid, and with the UTM grid as well. So what does it convert? We can do points, polylines or survey lines. We can do polygons, if you've got cuts and that kind of thing. Surfaces, pit shells, topography, solids, labels. It does it all. It's quite amazing. You know, complex surfaces that you might have and shells that you have, you don't want to rebuild them from scratch. It just converts them just like that. Like, it works just like a toaster. Like there's no crazy work to do. It's that easy. So our two sites, if you loaded them into one project, and you'd have Green Hills way down here, and Fording River sitting up here 92 kilometers away. Well, they're not really that far away. So the magic of Minesight, there you go. Pulls them nice and close together where they should be. And then when we look in here, you can see that we actually have drill holes that we both done that are intermixed. So we want to make sure we're not drilling on top of another site's hole, because we've already got that information. We can share it between ourselves. There's no big deal for that. And it works great. So we had, if you see this green dash line, this is the old model from the other site that they're still using. And we had we call it the super model. I built it with a couple of colleagues, and we made it a few years ago, and it's sort of this reddy brown line. But the only thing is we were never able to update the drill hole information or pick changes from the other site. It worked great from a Fording River perspective, but we were never able to get any new information from Green Hills operations. That was all static. So that was what we wanted to remedy. So, oh shoot. So what we did is we built a model. We took the origin point from the COUG model, and we extended it to go over top of our whole area here. And it's oriented at the same direction. Our previous model that we had for the super model, it looks a little off kilter, but it is actually what we considered east-west. It's just that our norths were different. And so now we have an absolutely rotated model at 328 degrees strike. And so our results, we were able to get a vastly improved model. The geology and geostats are able to be updated. It's a lot of blocks, like over 60 million blocks. And each block is 10 by 25 by 15 meters. And that means my file 15 is 9.5 gigs. I don't know if that's, if there's many people here who've got bigger than that. If you do, you can put up your hand, but, oh, you do, Sue? Oh, okay. Right on. So what this has given us is a framework for converting the entire mine to a new grid coordinate system, and that's going to be NAT83. And for acknowledgements, I'd like to really thank Andrew. Maybe I shouldn't say too much, but it was absolutely fantastic working with you. And you know, to be able to do this, it has made things so much easier. And without the scripting work that Andrew did, I don't know where we'd be. We wouldn't have this done here today. That's for sure. So it's a lot of thanks to him. And then Mike Purdue from Airborne Imaging, he was our contractor that developed the algorithm to correct for the change. And then also my manager here, Detlev Vanderveen, who's the superintendent of Fording River.
Thank you.